Hello, this is a recording to show you, to explain what is a join operation in a database. So right here we have I created two additional tables so that we can illustrate the concept of a join operation. The first table that I have created is called people. So when you look at the table people, it has an ID and also a name. These are the two fields of each row of this particular table. The name part is really just how we call people, how we identify people in the human sense. But the ID part is important because that's actually the primary key for each row. What that means is each row is guaranteed to have an ID that is different from the ID of any other row. And as a result, the ID is a unique way to refer to a particular row in this table. So what we'll do is we're gonna insert some items into this. So I'll say insert into people, and we'll specify the name here, and then we'll specify values. So this part here, name, is referring to what field are we going to specify, because we don't have to specify ID. It is an auto increment primary key, so it has to be there. So what we need to do is to specify a name. So I just say, okay, tag is here. All right, so we have inserted one, and then we'll insert some potentially fictional people. So we'll say Doctor Who, Darth Vader. Okay. Well, since we have Darth Vader, we'll have Luke Skywalker. We'll have Han Solo. We'll have Princess Leia, and so on. Okay, so with all of these entries added to the table, we'll do a quick select all, select every single field. That's what the asterisk means, is select all the fields from people. And not very surprisingly, we got all of these entries here. So the next thing we need to do is to look at the other table. Now this one is kind of interesting because oops, I think the table is just called likes. So this is what we call an associative table. Each row of this particular table has its own ID, which is not useful for this discussion yet, okay? Because remember, each ID is only useful to identify a particular row of the table that contains this ID as a field. So in this case, this ID has nothing to do with the ID of me, of Doctor Who, or anything. This ID is only used in this particular table that we call likes. Now, the other components are very useful or very important. The second field of this particular table is called who, and the second field is called whom. So combined with the name of the table itself, each row is expressing who likes whom. Okay, and so we can add some entries here. Now, the important part is we are not going to say Han Solo likes Princess Leia. That is how not we are going to do it. We'll use the ID instead. So what we'll do is we'll create an entry with 5 as who, and then we'll have an entry, the same entry with 6 as whom, in order to represent that Han Solo likes Princess Leia. So we'll do that here, insert into likes, and then we only specify who and whom as fields. And then the values of those two particular fields, one is 5, which is Han Solo, the other one is 6, which is representing Princess Leia. Okay, so now we have created one entry. We can also express that tag likes Doctor Who, so we can also specify that, and so we'll look up the ID 1 and 2. So 1 is who and 2 is whom. So insert into likes who, whom, and then the values would be 1 because 1 is the ID of tag, and then 2 is the ID of Doctor Who. So we'll do it this way. Now, you might ask, well, why don't we just spell out the names here? Like Tech and uh, Doctor Who, Princess Leia, Darth Vader, and so on. So why don't we just use the names here? Well, there are several reasons. One reason is our people table is relatively simple at this point. It only contains the name, but later on we might want to add some additional items to uh, people, such as birth date, things that are unique to each person. I take it back. Things that only relates to a person and only relates once, we can put it into this table. Since each person only has one particular birth date, so that can belong into the same table here. On the other hand, the phone number of a particular person really should not belong to this table because a person can have multiple phone numbers, and as a result, they should not belong to the same table. This has to do with the canonicalization, or making a table canonical. Um, so that's a whole separate discussion. We're not going to touch on that here. All right, so now that we have those two entries added into likes, so they will go ahead and select all fields from likes, and we see those two entries. Once again, this ID, the first column, is not really useful in this case. We might find a use for that later on, but it's always good to have a unique ID for each row of every single table, just in case we need it later on. But the second item, which is 5, is identifying Han Solo in this case, and 6 is identifying Princess Leia. And then on the second row, 1 is identifying me, and 2 is identifying um, Doctor Who. So now we'll do a join operation. So we'll say select star from. Now this time we are not selecting from a single table. Now this time we are going to do a outer join between um, the two tables that we have. So it's going to be, the first one is people, and we specify joining with likes, and then we specify that. And you can see that there's a lot of entries here. So what's happening here is it is crossing every single record, every row of the first record with every row of the second table. Okay, let me say that one more time just to make sure that I said it right. It's crossing each row of the first table with all the rows in the second table. And you can see that there are two entries here corresponding to the two rows of the second table, the likes table, but there's only one entry here. It is the same entry from the first table. And the same thing applies to Doctor Who. It applies to these two. Darth Vader corresponds to these two. Luke Skywalker corresponds to these two. Han Solo corresponds to these two, and so on. So this is what we call an outer join operation, where in MySQL or any other SQL, it is simply a join operation that has no constraints. So when it has no constraints, it's not really particularly useful. So let's just say that we want to identify who has someone to like. Okay, not liked by somebody, but who has someone to like. So in that case, we'll repeat the same thing here. But this time we want to add a constraint of the who of the second table has to match the ID of the first table, because this way we can identify, is who has an entry of liking, who has at least one person that person likes. So in this case, we specify in the where clause, and then we specify the constraint where people.id has to equal to likes.who. In other words, we're saying, okay, we're putting a constraint here so that we only allow the entries where the ID of the person, which is here, the first column, matches the who column from the second table, which is here. So this time, just by visually inspecting this, we can identify that. I'm just looking for the entries that should show up here. Oh, okay, I'm looking at the wrong thing here. Okay, so we are looking for this one to match a one over here. So since I like Doctor Who, that row should show up. And then since Han Solo likes Princess Leia, this entry should show up as well. So these two entries will be filtered, whereas all the other items will be filtered out because the people ID, which is this column, does not match the Who column of likes. Okay, so we'll press the Enter key, and then it specifies, okay, the error only has to do with having two semicolons here. I forgot that I had one here already. So that's a minor syntax error. But it should only show two rows in this case because only these two rows have, only these two rows represent, of all the rows here, only these rows represent the ones where the ID from people matches the Who from likes. Okay, so that's a join operation, but we might be interested in even more join operations here. So we'll join, so we have people join likes, and then we'll have it join people again. Now, when you do this, it's not going to work out very well because um, SQL cannot identify which people are we talking about because it appears twice. So I think we can refer to the second one as another name. So we'll say whom, and let's see if the syntax is right. Okay, the syntax is in fact correct. Okay, so let me show you what is happening here. We are having people, which is here, these two columns, and then we have likes, which is these three columns here. And then we have people again, which are these two columns. But what we want to do this time is to change the query so that we add something to it. So we want to say and, okay, so we still have the same constraint as last time, but this time we'll also specify and say that likes dot whom, the person being liked, has to match whom, the table itself, okay, because we are referring to the second people table as whom in the query, so whom.id, and the same two rows will show up, like okay, semicolon here. The same two rows will show up like last time, except this time we also have two additional columns compared to the last time. In other words, this time we can actually tell the name of the person doing the liking and also the name of the person who is being liked by the first person. Okay, so and the same thing for the second row. This particular table likes is called an associative table, where it is used to associate relationship between entries of two tables. And it is particularly interesting in database design because it allows a multiple to multiple relationship, because Han Solo can also like Luke Skywalker. Okay, I guess it's a different kind of like, but nonetheless, it is like. Okay, so we can add the entry here. So we say insert into likes. We have to specify the who and the whom and the values of those two. And we just have to look up here. Han Solo has a 5 and Luke Skywalker has a 4. There we go. And then we press the enter key. And then we run the same query as last time. And this time you will see that it has 3 entries. Han Solo likes Princess Leia. Han Solo likes Skywalker. And Tech likes Doctor Who. So it allows it, this is called, so we have 2 entries from the people table doing the liking part. But we can also illustrate how, I can like, Doctor Who and Darth Vader too. So we'll go ahead and specify that one. And I just have to find Vader's ID. Vader's ID is 3 and I'm 1. So we'll add another entry. So I'm just being lazy here. I am 1 and Vader is 3. So when we rerun that kind of long multi-join query, now we get these particular rows as a result. Now remember, each row of this particular query is not a row of a single table anymore. It is now a row of a join operation. And unless you specify individual columns, it is going to list every single column. So in this case, we have a true multi to multi relationship. Not quite yet. Okay, it only shows that we can have the same person liking different things. So we have to kind of illustrate how to do the other part here. We'll say that Luke Skywalker also Princess Leia likes Luke Skywalker as a sibling. So we'll go ahead and say insert into likes. And once again, the fields that we are specifying is who and whom. And the values would be, well, I guess they mutually like each other. So we'll have 6-4 first, which means Princess Leia likes Luke Skywalker. And then we have vice versa, like so. So when we rerun that long query to find out who likes whom, now we have a true multiple to multiple relationship, because we can see that Han Solo likes Princess Leia, but Han Solo also likes Luke Skywalker. And at the same time, we can see that Han Solo likes Luke Skywalker, and then Princess Leia also likes Luke Skywalker. And this is the power or the flexibility of using an associative table. Associative table is that it can establish multiple to multiple relationship in a database. And then the magic to get this to work is a query that is like this. Okay, the first part we are not too concerned about, because this simply means that we want to list every single field from the join operation. The second part is kind of important because, which is this part here, it basically says which tables are related. Okay, well that's why these databases are called relational databases, because they can relate to each other. So the joins are basically saying the table people relates to the table likes, which in return also relates to the table people. But since I cannot refer to people and people in the where clause, because then I cannot tell which version or which columns we are referring to. So that's why in the second one I have to rename that table people. When I refer to this table, I have to refer to it as the quote unquote the table whom, which is an alias of people as the name of a table. So this part here expresses what tables are related. Okay, but how are they related? That is specified by the where clause. So the where clause is really where the filtering occurs, because in this case we are specifying the constraint of we are only interested in the rows where the ID of people matches the who of likes. And on top of that, this is a conjunction, which means that both sides have to be true in order for the entire thing to be true. So the second constraint that also has to be true is the whom field of likes also has to match the ID field of whom. This sounds confusing because this in the second one, whom refers to people as a table, whom is the alias of people as a table. Whereas in the first one, whom is actually a field of the table called likes, but that is a constraint. So you look at this output here, okay, which is after filtering, and you compare that to the same thing, but without the filtering. So you just take out the where clause like this, and you can see how the one without the where clause generates a lot more entries, because what it's doing is it's actually doing a cross product between all three tables. For each entry of the first table, it is matching it to the cross product of the other two tables. And that's why you get every single possible ways of combining the three tables when you do not specify the constraints. But when you do specify the constraints, it is only filtering, and it's only reporting back the rows where the constraint itself is satisfied. And that's why we only get 6 entries in this case, as opposed to 216 entries. when you look at 216, you can probably guess why it is 216 due to the sizes of each table. When we look at the number of entries in people, oops, misspelled, sorry about that, people, it has got 6 entries. When you look at the number of items from legs, it has got 6 rows as well. So 6 times 6 is 36. 36 times 6 is 216. And that's why, when we look at the join with 3 tables without any where clause, it has 216 items. So I hope this kind of helped to illustrate the join operation in a database, both conceptually and also mechanically, how to do it. If you have any questions about this video, please do not hesitate to ask me using the forum or just sending me a text. I'll be more than happy to make another video to help clarify concepts that are not explained clearly in this particular video.